joskus hyviä tuloksia ja joskus aivan naurettavia tuloksia, jotta saataisiin jonkinlainen käsitys siitä, että mistä tämä johtuu tämä kaikki, minkä takia se tekee niin kuin se tekee, niin meillä on täällä nyt paikalla asiantuntija, joka pystyy sanomaan, mitä konekääntimen pään sisällä tapahtuu. Eli Jörg Tiedemann kertoo, miten konekäännös toimii. Jörg, if you can make it shorter, that would be great.
Okay, I will see if I can manage to. Let me get the full screen. Okay, I was asked to talk about automated translation, how this works, and I think in the program the title is actually in Finnish, but I don't speak Finnish at all. And maybe I can also start by replying a little bit to the discussion just before the break. And maybe I can respond to the people discussing there that maybe you really underestimate the use of machine translation for everyday use and for users who are really in need of this technology. I can just tell you from my experience from moving to Finland last year, I would have had a much harder time moving to Finland without translation services that you have online. And you know which service I'm talking about. So there's a lot of services that I couldn't access. A lot of information that I needed translation to, and this really helped me a lot. It's a great help for me. And I try to convince you also that you should support our research goals that we have in developing this kind of technology. Now giving you an overview of translation technology in 30 minutes is not really possible, so I will just give you some intuition. I hope that this will turn out well. Now I borrowed some pictures from other people, like this one from Kevin Knight, one of the leading researchers in the field. And this is also coming back to the topics that we have talked about, that there will be loads of things that need to be translated. There will be lots of volumes, and what is the purpose of technology? It's of course to make our life easier and to handle these large volumes. So any kind of technology we develop in any subject is related to making life easier. And especially also if you have translation, a lot of translation is a lot of repetition as well. Repetition that makes the task really boring for human beings, but then you have technology and computers on the other side who like repetition and don't care about this boring task. And of course, automating things makes sense here, because now we can really concentrate on the interesting parts for humans and make automated processing for these boring parts. Something that we have also talked about already is that there's of course a difference between what is the task, what you actually try to achieve, and how do you actually produce that. So we have talked about source language restrictions and so on. Basically, I'm not really a big fan of restricting the source. Instead, we should develop our systems to handle normal language. But of course, with the current technology, you can really try to achieve quite high quality translations if you restrict your input source. But also you shouldn't forget about these other purposes that I've talked about in the beginning. So if you want to have access to information and would like to just have some gisting service, this is really useful if you have, for example, this online setting. And I use that a lot. So you could call that a browsing quality if you have a general purpose translation tool. Then we have this scenario of post-editing, and of course you were thinking much about this kind of process. So that machine translation is only a tool in this entire workflow, trying to use this as a tool for improving the quality from some automatic translation to perfect translation. And maybe if you restrict yourself even more, so you have something that is more like a sub-language restricted domain, then probably you can achieve this high-quality translation, as we have said already before, for manuals in airplanes or different things. So this is not completely new. Of course, you want to know how does it work. So this is the topic what I was supposed to talk about. So I think in research and also in the development, it basically tries to imitate what humans can do. Humans can do translations. And then now we want to see how can a machine also become a translator. So probably we have to look at how does it work to become a translator, and how does a machine can model the same kind of process. And then we can, well, maybe I simplify things to certain degrees here, of course, but of course then learning the language, understanding language is must be the first part. So understanding language meaning that we have to recognize patterns, we might have to find these linguistic items that have relations to each other and of course relations to the real world. We have to make these kind of generalizations and abstractions. And in the end also, of course, not only understanding the language, also knowing how to generate or speaking the language. So a human has to remember things, repeating things in the beginning, but then probably producing new utterances on the fly, and then trying to learn, really become fluent in that language. And then this translation part is, of course, that you do this for several languages, but that you also try to find the mapping between these languages. So becoming an empty system is basically the same, I would say. There must be some way of learning to understand the language, so finding these patterns, recognizing them, finding abstractions between these patterns on these linguistic units that you find. And the link to the real world is still kind of missing in most of these approaches, but we should also work on that, of course. So imitating what humans can do by trying to teach the system also to learn that kind of abstraction. So there's several things that are related to work that we do in language technology. So there's natural language understanding, which is this understanding part. We have language modeling and generation, which is this speaking part, let's say. We can generate language which is fluent. And then we have the mapping between languages, which comes down maybe to some process that you could call alignment, transfer, or any kind of process that tries to make this mapping between languages. Okay. So maybe I can do this rather quickly because I think we all know that translation is really a difficult process. And despite of the fact that in the beginning of the maybe 40s, 50s, 1940s, 50s, where people believed that this will be a quickly solved problem, we know that translation is quite a difficult problem to solve. And here's just to show that it's really difficult to evaluate also quality of translation. So if you ask people to judge the quality of translation, they will have much different opinions about that. And it shows that there's a lot of flexibility which are difficult to judge. And there's many facts why this, many reasons why this is such a difficult task to actually evaluate. And all these facts and properties also make it difficult to model this as an automated process. Kimmo asked me to be quick, so I'm going quicker on that because that's something that we can probably skip. So let's look at language technology and machine translation. Why is machine translation so interesting for language technology in general? It somehow integrates lots of different things that we work on. So in general, language technology is about building computational models from human language. And we have this understanding part. Maybe we want to understand what is the meaning behind that message, and we want to speak or generate, for example, some output language. So this basically is the general goal that we have in language technology, trying to manage doing these things. So if you put source and target language on both sides, we basically get to the point of machine translation. So machine translation is for us a research goal that summarizes things that we want to do. So you are more interested in the end user product, but let's see, there's also really a research goal behind this. So let's look at some practical solutions. There's possibilities of doing some shortcuts. It's really difficult to make full understanding, and we are not there yet. So probably we have to be down at some other stage where we do some transfer on an abstraction which is not completely the fully understanding of the message. And we can divide probably the field in two different ways. There could be expert-driven systems, meaning that an expert is defining how to actually do this analysis and the understanding part, also the transfer part and the generations part. And then we have this very popular data-driven technique that I think all of you refer to when you talk about machine translation. So both parts exist and both parts are explored, of course. I will talk mainly about this data-driven part because this is also the main topic of this workshop, I think. Data that really gives possibilities of learning. Okay. Speed up again. So, what is the advantage of this data-driven approach? So, in some sense, this tries to model the way of learning from experience. So these human translations really naturally appear, like humans would listen to other language, and there's no need for some kind of artificial annotation or formalism that you have to give to the system provided by some expert. But instead you can actually provide the translations as just naturally appearing text input. So that's of course an advantage, and you can just put more information into a system by just adding more data. Then also maybe similar to human learning of languages, you try to find these patterns more in an implicit way. So instead of learning by heart what kind of grammatical structures you have to see in the text, you find patterns on a regular basis just by looking at the things that you observe. So there's translation knowledge in the data. This is this implicit linguistic knowledge that you can extract by using distributional methods. And another thing that is really interesting here is this constant learning phase or process that also humans, of course, facilitate over the years is also just built into the system. Because now if there's more data coming in, the system can, of course, adjust, adapt, and learn more. So that's also one of the big advantages of data-driven techniques. So how does it look like in this picture here again? So now we have human translations, one of the sources. We need data, of course, otherwise the learning is not possible. And we have also a lot of target language data, which is really necessary for doing a good modeling of the target language. And as you know, as translators, it's really important that you're really fluent in the target language. So we need a lot of experience for producing fluent text in the target. So it's not only about providing translations, but it's also providing the monolingual data for the target language, for example. So we shouldn't forget about that. So we call this translation modeling, language modeling, and you can say that this somehow corresponds to adequacy, so the translation mapping between languages, and fluency in the target languages. All right. So if you have this kind of model, then in research this is often called decoding, so somehow makes maybe translators worry that we are trying to make this too much into an engineering approach so that we decode secret messages. But it's this search problem for some kind of likely translations using that model that we have estimated. And the estimation part is then certainly a learning algorithm. So we try to model learning algorithms nowadays that simulate learning from, or not simulate, that provide the learning procedures from that data to this kind of empty model. So if this is done, decoding is basically a search algorithm, as I said before. So now there's a model that can explain mappings and can explain how to produce fluent sentences. And now we have to search for a given input what kind of output or translation is the most likely one, for example. So that's also something that maybe relates to human translation. You're not, probably each human translator would also be able to produce a lot of different translations. And most translators will always produce different translations from other translators. So also the search algorithm would be able to give alternative translations and maybe rank them according to some internal likelihood that is implemented in the system. Okay. So, and this summarizes once again, so we try to build in these data-driven techniques some probabilistic models. So there's a probabilistic translation model which not looks at the exact translation. There's only one way of analyzing the text and one way of translating this, but instead it looks at the likelihood of a certain target language sentence to be a good translation of that source language sentence. So we have to model some way of generating this likelihood inside of the model. And to make this possible, we need to decompose models into different components, and these components need to be combined. That's also how humans, they use different kinds of components and they know how to combine them. So that has to be learned by the system. And this language models part is then also, in a similar way, a probabilistic model where this gives a likelihood for the output so that we know what is a fluent sentence according to our model, what is the most likely fluent sentence that we can produced by combining these different components that the system knows about. I hope this all makes sense to you. Okay, now coming to some more details, and I've said I cannot really provide you all the details here, but just give you some technical background as well. So if you have translation as this decoding process, so now we have some system that can give likelihoods. So translating means then that we have to find in the entire space of possible translations, possible ways of producing sentences in the target language, we have to find the best translation according to our model and the input that we have seen. So this is a huge search problem, and the search problem has to be done in an efficient way. So here we have a lot of different ways of producing this, and this of course comes down to, well, you have to know what kind of combinations your different components can take, and how you can produce or compute this likelihood given these different combinations. So in the bottom here below, that's a picture from that is called phrase-based machine translation, where there's some kind of hypothesis expansion technique, where you start from left to right basically, and you add different elements to the sentence, and then you have different ways of expanding a given initial hypothesis, and then you get some likelihoods for the entire translations in the end. This picture probably doesn't tell you so much if you don't know any, but if you don't have background in this field, but that's also not the purpose of explaining these details. You see, in the interest of time, I maybe skip this. This is just a historical list of what kind of systems have been proposed in this data-driven framework. But I can tell you there's a lot of tools and methods available, so this makes it really easy to get started, but difficult to actually advance because there's many problems, of course. I also want to give you some intuition. I hope this is a good way of this is usually what I do with students, and this also comes from Kevin Knight's presentations on statistical MT. So how is it possible that a system can learn from just translations? How can it be possible to find patterns? And I said something about this distributional properties that we can find. So if you think that this is our translation memory here, we have just a few sentence pairs that we can look at, and we now have to learn from this here. And I just simulate here the same situation as a computer has when it gets this kind of text here. The computer doesn't know anything about those languages, so I hope you don't know these languages either. And now your task is to find, to translate that sentence in the top part. So students usually have the task then to think about this 10 minutes and then come up with some ideas. So let's just assume that we can see there is some repetition and some distributional factors. So we can think, for example, that we have a very simplistic word-based model, and we just want to find out what is the translation of that first word. We find out it exists only in 2 cases, and in these 2 cases we have another word in the target language which is only in those sentences. So it really seems to be a very constrained thing that this tries to translate or refer to, and we can make a guess that maybe this is a good connection. Now this is a starting point. You can think of some kind of detective work here, finding out what are the patterns that make this or explain how this could be translated. And by making connections and connecting more things, then things become more restricted, and you can make some more decisions. And that's what also the statistical system does, tries to find these patterns that repeat and translate, and together with all the other information that you have in surrounding context, you can find more information about what things can be connected. So I don't want to argue that this word-based model is now the perfect model here, but it's a way to get started to just finding out some translation patterns here. So for this language, you could then in the end, if you continue this process, find out what are the individual word translations. So I said, I don't say that this is the model that we are working on. But let's assume this is just a way to explain that patterns can be found without actually giving the input of saying that this word translates into another word. You just get it from the data. It's not given by anyone. So this shows that this kind of unsupervised learning is possible. Now this was a trick just to change the language. It was actually this, is it Spanish, English, I think. So here you can see, if you know the language, of course, this becomes obvious. But if you change that language to something that you don't understand, it's not such an obvious thing to do. Now assume you have a lot of data. You hope that you can find these patterns easily. Okay, some more details. How do I do with time? It's okay. So, just to give you some of the models that are really in use. So there's these phrase-based models, which are the terminology is a bit misleading. It's not really linguistic phrases, but sequences of words that we try to put into some translation models and the translations for these sequences. So if you can, for example, link individual words, which are now denoted by these black dots here in this matrix here. We have source and target language. We can extract fragments that are translations of each other using these different dots that we have in the matrix. So here's one example where you can get, for example, this called phrase here. This is some comments corresponding to die entsprechenden Anmerkungen. So this is something that we can extract, and using information of repetition, we can estimate some likelihoods that this is a good translation pair. So assume you have lots of data, you can make some abstractions. So what you do in training, you extract all these phrase pairs, you count frequencies, and you can estimate likelihoods. So something that is a bit more interesting here is that you can also do, for example, some abstractions here. I said you have to learn some abstractions here. So you have, for example, these models of hierarchical phrase translation, where you can do the same kind of extraction process, but you say that also some subphrases can be extracted from those. So inside of a larger sequence, there's a smaller sequence that also correspond to each other, and we can replace that by some variables. And down here you can see an extraction of a phrase that has this variable x, and that can be a translation rule that is learned from the data from the alignment that you have. So you have where x Aushändigen should correspond to this shall be passing on an x. So we hope that you can also learn some generalization in this way. And now getting even further, you can of course also use explicit linguistic knowledge. So if you would have explicit linguistic knowledge, like for example phrase structure trees on both sides, you could also assume that you can extract linguistic rules mapping from one linguistic representation to another linguistic representation, so that you transfer from on a syntactic representation to a syntactic representation. So you can see you can advance this to more sophisticated ways of producing these translation models. So if you probably think of in your everyday use as machine translation as a lookup in your translation memory, it is much more. Don't underestimate the research in machine translation. There's a lot of things going on. So here these most common models that you might see. This phrase-based model where you have some kind of sequences of words that you can translate individually and shuffle around. You have these syntax-based SMT models where you have a hierarchical structure. So you can do some hierarchical structure and mappings. And now the new thing is these very upcoming approaches where you use neural networks, where you have some internal abstractions which are not given by some syntactic structures that you can actually read, but there's some sub-symbolic representation of these different parts and components which are learned by the system. There's no time to explain all of this, of course, but just to give you an impression that there's a lot of research and development going on here. So it's not just a lookup. So I was also asked to say something about the situation for Finnish, but I think many other people here would be much more, would give a better picture on that. So I just give you some impressions from my view. Let me see what, so I was also looking at the white paper, which was already cited. So there's something that says that Finnish is still one of these languages that is badly or not well supported by translation services. So there's a lot of cases where this really fails. But this is really gradually improving, as you can see, and my experience is also this translation to English is really helpful nowadays from Finnish to English. I used it a lot. But of course the quality is quite poor. Let's look what happened when we participated in some shared task on translating Finnish to English and English to Finnish. So this is our winning contribution, and here's some scores that might not tell you much. But so just comparing them to some standard approaches where you have French-English with a bleu point of 33, we get down to half of the quality of the translation if you translate Finnish to English even. And English to Finnish is even worse, so there we have some quality that is really still lacking a lot. Okay. So you might wonder what is wrong with Finnish. So from engineering point and research point of view, you just say that Finnish is just a language we should forget because it doesn't fit our needs. So of course there's no problem. The problem is that the models are not well developed for actually handling Finnish. And I want to convince you that you have to push more resources into research to actually handle those languages. So that's what you have to do with providing data and giving the possibilities of working on these problems. So let's look at these standard approaches that I was talking about. Of course, you haven't seen all the details, but you can, of course, imagine if you just have surface strings, you chop them into different segments. There's a lot of problems with inflection, all these agreement problems, some derivations, compositions, and morphophonological alternations that I say here. So all of these things that SMT or statistical MT doesn't really work well with, that basically describes Finnish. So that makes it, of course, obvious why this is not working well. So I just skip those things. You know this better than I do. So there's a lot of problems with Finnish, and this should be something that we have to address and develop things for. And that's, of course, again, if research is really funded in such a way that there's a lot of development focused on English, we get publications only if we work with English. There's a lot of publications that refer to English, but only a few ones for Finnish, even if they come from Finnish research institutions. So that's really bad. So, what do we need to change? We need open resources and tools. And I think in this way also that you shouldn't give your open resources and resources to the European Union, but you should really support research. I mean, we have this natural interest that we want to develop those systems further. So if we don't have tools and resources available and they kind of disappear maybe in some companies, that doesn't help us, people who have this natural interest in developing public tools. So definitely, if you have data resources you're afraid they are too noisy, we don't care. We would like to have them, all of them, because this makes it interesting. Challenging problems are really interesting for us. So now, of course, we need some funding. So if there's no funding for basic research, we cannot do anything. And this integration of workflow is, of course, then something that we should do in combination with the end users. So this would be a different phase of that development. So I should finish up, right? So this is my last slide. What I wanted to say is data-driven machine translation develops quickly. There's a lot of ideas, a lot of things that develop now. Please support us, give us the data. There's various models, there's a lot of different research going on, and we would like to be supported in this way. And I can stop here. Thank you.
Thank you, Jörg. You probably beat the world record in explaining not only statistical machine translation, but all methods of machine translation in less than half an hour. So that's quite remarkable.